The hinges for the sheet metal task are probably the hardest part of the entire task that you're going to be producing. So we're going to be looking at forming this section here. This is an overall view of how it's going to look. We're going to concentrate on this section. More specifically, we're going to be concentrating on this wraparound section here. This is the bit that's going to actually form the hinge itself. It's called a wide edge. It's another way of making a safety edge as well, and can be used for reinforcing boxes, etc. But in this instance we're going to be using it as a hinge. Notice we've got a wrap round about 330 degrees around the rod that will sit here in the centre. So if you've looked at your sheets, you'll probably see something like this, which is one of the toolbox hinge pattern development layouts. So we need to concern ourselves with what we've got going on down the bottom here. As you can see, there is a 9mm line here, and that 9mm is the extent or the length of the actual wrap round for the hinge. So if we look at the close-up of that, what we're going to do once we've developed the pattern is we're going to then scribe another 2 lines in to subdivide this 9mm, and what you'll end up with is a line at 3mm, a line at 6mm and a line at 9mm, and that's going to be the start, the initial phase of producing your curve. So what we're hoping to achieve once we've scribed those lines and then we've put them in the folder, I apologise this hasn't come out very well, we'll have the flat piece, which is the main part of the sheet. Then we'll have a bend, the first 3mm, then another bend, and then another bend. And they're all about 60-70 degrees in an ideal world, and you'll end up with something which is not a million miles off a complete wrap round. The reality when you do this on the bender is you'll find you're not going to get anywhere near as tight an angle on each of these, and in fact in reality you'll probably be lucky if you don't end up with something which is more standing upright than fully wrapped round, as you can see there. We know this is going to work, and there's a little bit of math thrown in, as there always is, because we have here a 3mm diameter piece of bar, and we know that the circumference is equal to pi d. Pi in the workshop we generally refer to as just being 3.14 blah blah blah. So 3 times 3 is 9mm. So very quick and dirty way to work out whether you've got enough material to wrap around it is just by using pi. So simple bit of maths to get us started. That unfortunately is the easy bit. Now we need to start shaping and forming the metal. Right, broken out my homemade rather clunky sheet metal bender, and all I've done is got a bit of scrap material. I strongly urge you to try this with scrap first. It's going to cut an awful lot of time and effort out of producing these bends and hinges if you get some practice on sheet metal first. You've still got plenty of time. This is going to be the most time consuming part. If you go through all the effort of cutting out the pattern development, getting it all shaped only to mess up the hinges, you're going to add hours onto your work time. Get some scrap from beside the guillotine and just practice, practice, practice. 2 or 3 practice sessions at trying to produce these curves are going to make life a lot easier when it comes to the actual real thing. Much faster to practice on this rather than on the actual finished product. So I'm going to put them in the bender. It's going to take me a little while because this is quite old, clunky. Well, it's actually very new, I only just made it, but it's an old design, very clunky to use, not very interesting for you to watch. I'll get it bent up and then we'll start looking at forming the shape. Right, let's look at the setup. What we've got in this case, I've got a little tiny steel bench, very thick, very heavy. You've got lovely great big cast benches at CME that make this very much easier. I've attached to it a backstop, so the solid plate at right angles to the bench, which cannot move. You've got those already installed on specific benches just for this task. So you've got much better advantage than I have in getting this done very easily. The next most important things are hammers. Now I've got less of a selection of hammers than you have, so you're going to be using something about this sort of weight. A nice small hammer. You'll be using a cross peen hammer, so it won't have this ball peen on the end of it. What it will have instead is a more pointed, flat kind of blade. I don't actually have one of those. Now I could use this hammer. This hammer does have a distinct disadvantage when doing this work, and I don't know if you'll pick it up on the camera, but there is here a big chamfer. That chamfer's got a lot of advantages. It means if you come in with a hammer at a slight angle, the sharp edge doesn't dig in and cause a big dent and piece of damage to your work. But it has a disadvantage in I can't get in really tight with it. So although this is the right kind of weight, this isn't the hammer that I'm going to be using whilst producing this curve. I'm going to use more of a metalworker's hammer, sheet metal working hammer, like a planishing style hammer, which has got very, very small chamfers on the edges, which means I can get in much tighter. Apologies, it's not as clean and shiny as it should be. I do get a little bit misused, but it's worth remembering that the cleaner the face of your hammer is, the less dents and nicks it's going to produce into the sheet metal when you start actually working on it. So always just check your hammer. If it's got big gouges and scratches and dents and lumps sticking out of it, it's probably not the one to use, and just give it back to the stores and see if they'll clean it up and get a nicer clean hammer. But if you use the cross peen hammer, it will do exactly the same job as this, and as Mehmet will show you, actually has some advantages when you're doing the sheet metal work. Right, a piece of steel, as you see, it sits nice up against the back plate, so that gives us a massive advantage. It means that as we hammer into it on the side, we're not expending all our force moving the material, and I can show you that if I hold it in place, just apply the hammer, no matter how hard I hold it, every blow pushes it in this direction, which means I'm expending an awful lot of energy and getting no results in the metal whatsoever. However, by putting it up against this back plate, that means any blows that I apply to it in this direction get transferred straight to the bit that I actually want to change the shape of. So first job, remember we're wrapping it round your 3mm hinge pin, which we got here. First job is, well, it needs to get a little bit closer. It's miles away at the moment, so initially we'll leave the pin to one side a minute and we'll just concentrate with the hammer. And what I'm going to do is get this edge here to start coming over in this direction, and to do that I'm going to hold it against the back plate and I have the hammer actually on the bench. I'm not going to lift it up, on the bench, and all I'm going to do is slide it. So starting off, just going to go in, start from the top and work their way along, and I'm just going to apply really gentle blows, and you'll start to see the shape changing and moving with each little blow. Almost imperceptible. We're coaxing the metal here. We're not beating it into submission. There should be no need for full-bodied blows with a hammer trying to smash it into position. We're just giving it light, gentle taps, and each one moves it 1/4 millimetre, just a little bit at a time. It is very much that kind of procedure. It's slow and it's gradual, but that's the way to shape metal. If you try and move it in one hit, all you do is cause a deformation of the material that you'll never be able to get out again. So it's starting to come over. Now what I want to do is get this top edge here to start curling in a little bit. I want it to start coming down towards this metal. So to do that, what I'm going to do is I'm going to leave the hammer on the bench, but I'm going to angle it so that the face of the hammer is at the angle I want the metal to bend to. So just holding it not even 45 degrees, probably about 30 degrees, and then sliding it on the bench and doing exactly the same thing, working my way along, looking for bits that are at a slightly different angle. Covering the whole face of it. And now we're starting to get a bit of a curl coming in. We can start to see it's starting to form the shape and it's starting to come down. So again, patience, keep going. And we'll start to see that's really getting quite close, and it's because we're using gentle blows and each one is just moving it slightly, it's naturally forming a curve. Those flats that we had from the folder have disappeared and we've got now a more gentle curve coming in. And we can start to have a look what the rod looks like. So there's my rod in there, it's getting there, it's still got a ways to go, but I can now start forming it down. So now I want this top edge to start coming down and meeting that rod. And that's fairly easy to do. Rather than being on the bench now, we can just apply load directly down. Now notice the sound that the hammer makes, notice the movement that the hammer is making. I'm holding it just in my thumb and forefinger, just a light grip on it. The hammer is able to move around. And they are just there to act as a pivot. And all I'm doing is lifting it up and letting it fall down. I'm not really putting any effort into it, I'm just lifting it and controlling where it falls. So the only thing that's doing any work is just the weight of the hammer on its own. So working from the top again, and we're just going to those gentle blows. Sometimes at first you think there's nothing happening, and then you start to see it's moving. Just gradually creeping down. Now if I was to give this one big heavy hit, the whole thing would just collapse and I'd have a big crease line and it would be completely ruined. So you've just got to be slow, careful and patient. And now that's getting towards having starting to wrap around the rod. I'm going to hold the rod in place now and carry on doing the same. And just looking at it, from where I'm looking, it's just starting to come away from the rod. So instead of hitting from the top, I'm just going to use some side blows against my backstop, and that'll just get it to curl over a little bit more. And you can use this edge and look at the rod and line the two up and see if it's leaning one side or another. So if this side is a lot further in this direction, that means I need to bring this one over, and I can do that just by those gentle taps, and that'll just help that curl round a little bit further. So line her up. I'm just continuing to work down from the top. Now I'm coaxing the metal here, so what I'm doing is rather than hitting straight down, I'm using a sweeping action. So as it hits, a little bit of friction just drags the metal in the direction it wants it to move. You're not going to move it miles, that's not going to happen, but you're going to get a little bit of motion in the direction that you want. So the whole process is just about watching. Where's it moving? Where's it need to move? Where do I need to apply the hammer blow? And that's why practice is so important, because you won't have that skill yet, but with practice it'll come. Now I've pretty much gripped the rod there, and what we've got is kind of a C shape. So it's gripping the rod but it's not holding it, it slips out. So what I've got to do now is get this edge to start curling round to really hold that rod permanently in place. Now I could try and kind of hold it against the backstop here and then try and sort of come in sort of at an angle and knock that down, and it would be really difficult with the tools that we've got. So there's a much easier way of doing it. We want this piece of metal here to move down towards the rod. So I just need to stand this at the angle that allows me to hit straight down and get it to move to the position that I want it to. So we're just going to hold it up, try and keep the rod in place, and just start to tap her down. It won't do anything initially, and then you'll start to see we're getting a little bit of wrap coming in, and it's holding it in place. And once you've got one edge and that's gripped it, it becomes an awful lot easier, and you can move to the other edge. Just get it held in place and do the same, and actually get it to just come round and nip onto that rod. And now that's held in place, I can really go to work and I can shape the rest of it without worrying about what the rod's doing. So I've got a half decent wrap formed around there now. It's not all the way down, it's not as tight as I would like it, but we're nearly there. Now if it's a little bit far out, if there's a big gap here, and I have got a bit of a big gap down there, I can actually send a bit more metal over that way, just by again laying it on its side and tapping it across, and you'll start to see it moving and changing its shape. And that'll help you when you do the full rod as well, because you want to make sure that this lines up perfectly with the piece of metal that you're using, so you can actually use that to keep it running parallel and actually change its position relative to the rest of the piece of metal that you're working on. I've carried on doing a few more. You don't need to watch me hammering a piece of metal for 10 minutes. And we got it pretty much into shape now. It's a little bit wobbly. You've got a little nice finishing tool that you'll run over there, which will get the shape really nice. I haven't got one of those here. You'll see it on the drawings in your pack. What I want to do now is just tuck this edge in here a little bit to get it to really come in nice and tight. I can get so far with my hammer, but I can't get it to really get right in and become at 90 degrees to the sheet. So the easy way to do that is with the edge of the bench, or in your case with the edge of the large blocks that's been bolted to the bench, and we can just sit it on that straight edge that we have, keeping the metal nice and upright on the side, and then we can use the fairly sharp edge that we've got along the side of the bench to actually just fold that last bit in and just run along backwards and forwards. You won't really see much happening, not going too mad, and that'll just tuck that nicely in, and that'll give us now what we have, which is a fully working hinge. Clean it up by running the former over the top with the hammer. Again, lots of little tiny blows, so hold the former on, just bounce the hammer along and move it a couple of millimeters at a time, working all your way down, and you'll get rid of the little lumps and bumps that I've got on mine. But that's your hinge formed. Be careful, if it takes you more than 15 minutes working on a section about this long, you're going to start to run into trouble, which is work hardening. Work hardening happens when you're constantly pounding on a piece of metal, and it actually changes the metallurgy of the material, and it goes from being fairly soft and ductile to being very hard and quite brittle. When it reaches that point, no matter how hard you hit it, how much more you hammer it, it will not move. So if you start to see you've got millions of tiny dents on your metal, and no matter what you do it's not changing shape, my suspicion is it's work hardened, and at that point stop, start again, because you'll never get it to form the shape that you need it to. So the trick with this is light blows, lots and lots of little light blows, no full force, very gentle, just little bouncing moments. That's the noise you should hear throughout the workshop. It's a cacophony that will spread throughout. See me when everyone's doing sheet metal. You can hear it all over the building. Don't expect to hear, because you're hitting too hard and you're just going to damage the material. Patience, slowly moving the material. Just take your time. Practice it a few times, and when you're comfortable enough that you can produce a reasonable curve that Mehmet's happy with, then go on and do the actual hinge. Don't jump straight in to do the hinge without doing a couple of practice runs, because chances are the work you put into cutting that pattern into shape will be wasted and you're going to have to cut it again. Thank you very much. Good luck with your hinges.